students, I am Nilanjana Sanyal, an online math tutor from India. Welcome you all to my channel NS Online Math Classes. Our today's topic is the binomial expansion and Pascal's triangle. This is our second and the last session on this topic. In our previous video, we have learned about the binomial expansion, how to get the different terms of a binomial expansion, how to get the coefficients of the terms using the Pascal's triangle in detail. And in our today's session, we will be solving few questions on binomial expansion, and we will be getting the coefficients of the term using the Pascal's triangle. And in the process, we will be knowing about the difficulties that we usually face when we use the Pascal's triangle to get the coefficients. Okay? So, without any further delay, let us start with our today's session. Now, the first question says, find the binomial expansion of x minus 1 over x to the power of 6. We have learnt about the binomial expansion in our previous session, and that was a plus b raised to the power of n. A plus b, these two are the two terms. So, this expression is a binomial expression because it contains two terms. And this binomial expression is getting raised to the power of n, and the terms that we will be getting will be the binomial expansion of a plus b raised to the power of n. The terms that we will be getting by actual multiplication. And that will be taking quite a lot of time. Therefore, we use the binomial expansion technique using the Pascal's triangle, and later on we will be learning about the NCR to get the coefficients. But the two terms of this binomial expression are connected by this plus sign. Whereas in our question, again this is a binomial expression. X is the first term and 1 over x is the second term. But these two are connected by a minus sign. So how do we change this expression, the binomial expression, to have a plus sign in between? Let us start with our answer. X minus 1 over x, this is a binomial expression. This can be written as x plus negative 1 over x. Okay? If we write x minus 1 over x as x plus negative 1 over x, then we are getting this plus sign in between the two terms. Okay? And a and b are variables. So, a in this case is having a value of x and b is having a value of negative 1 over x. Okay. Now we are in a position to use the binomial expansion. The binomial expansion rule that we had used or we had learnt in our previous session. Okay. So, x plus negative 1 over x is getting raised to the power of 6. And since the n value is equal to 6, therefore, the total number of terms will be equal to 7. Okay? And what will be the coefficients? First of all, let us get the coefficients of those 7 terms. For that, we will be needing the Pascal's triangle. So, the first row of the first Pascal's triangle, let me start over here. This is corresponding to a plus b raised to the power of 1. Next, 1, 2, 1, this is for a plus b to the power of 2. Then 1, 3, 3, 1 to the power of 3. 1, 4, 6, 4, 1, a plus b raised to the power of 4. 1, 5, 10, 10, 5, 1, that is a plus b raised to the power of 5. And then it is 1, 6, 15, then 20, then 15, then 6, and finally 1. You see there are 7 terms. 1, 2, 3, 4, 5, 6, 7. Okay, 1, 2, 3, 4, 5, 6, 7. There will be 7 terms and these are the 7 coefficients. Okay, so we can write this. I have to get some space, so I come over here. So I write this question once more. Negative 1 over 6 to the power of 6. This is equal to, we start with the first term's coefficient, that is equal to 1. X to the power of 6, because the first term, that is a, this is a and this is b. The first term's power of a will be equal to the value of n, and the powers of a will be going on decreasing by 1, and the first term and the last term's power of a will be equal to 0, whereas the first term's power of b will be equal to 0 and the powers will be going on increasing by 1, and the last term's power of b will be equal to the value of n, which in this case is equal to 6. Okay. So it is 1 times x to the power of 6 times negative 1 over x to the power of 0 plus second term's coefficient is 6. So 6 times x to the power of 5 times negative 1 over x to the power of 1 plus 15. 15 x to the power of 4 times negative 1 over x to the power of 2 plus 20 x to the power of 3 times negative 1 over x to the power of 3. Okay, so we come to this line. It is again 15 times x to the power of 2 times negative 1 over x to the power of 4 plus 6 x to the power of 1 times negative 1 over x to the power of 5 plus 1 times x to the power of 0 times negative 1 over x to the power of 6. You see the symmetry, 1 and 1, these are the first and the last terms of every row, and this 2 is the single middle number. When you are having 2 3s, so you are having, when you are having a total of 4 terms, the 2 n terms are equal to, each is equal to 1, and the middle 2 terms, they are equal to 3 and 3. Both are equal to 3. And when it is coming to the 1, 2, 3, 4, fourth row, it is 5 terms, and the middle 3 numbers are 4, 1, then 4, it is increasing from 4 to 6, it is increasing, and this is the largest number, and then again it decreases to 4 and then to 1. Okay, this is the way that it is increasing, in the same way it is decreasing. For this 1, 5, 10, since the number of numbers or the coefficients in this row, the 5th row, is 6, whenever the number of terms in a row is an even number, you have the largest number repeated. And the way that the numbers is getting increased, the same way it gets decreased. Okay, this is the pattern. So now we have done the expansion. We have expanded. If they say that keep it as it is, we will be keeping it as it is. Because they did not say anything, we will be simplifying as well. But if the question is do not simplify and give only the binomial expansion, this should be your answer. Okay, but since they did not say anything, we will be simplifying. So the first term is x to the power of 6. Second term, 6, it will be negative. So, because negative 1 over x to the power of 1 is negative 1 over x. And x to the power of 5 divided by x will be giving us x to the power of 4. Plus 15 x to the power of 4 in the numerator and x square in the denominator. Because negative 1 over x whole square is 1 over x square. So x to the power of 4 divided by x square is x square. 15x square. Fourth term will be having a negative sign. It will be 20 times x cube in the numerator, x cube in the denominator. So this is a constant term. Does not have any x. Next term, 15. And over here, numerator is having x square and the denominator is having x to the power of 2. So it is 15 over x square, or 15 times 1 over x square. Second last term, 6 minus 6 rather, x to the power of 1 and negative 1 over x to the power of 5. So negative x to the power of 4. And finally, 1 x to the power of 0 is 1 and negative 1 over x to the power of 6 is 1 over x to the power of 6. Okay, so this is our answer. This is the binomial expansion of x minus 1 over x raised to the power of 6. Okay, we are having 1, 2, 3, 4, 5, 6, 7. 7 terms. So let us move on to the next question. Expand and simplify 2x plus 3 times x plus 1 raised to the power of 4. So first of all, we have to expand this part. Only after that can we multiply. Therefore, let us start with our answer. So first of all, we do the expansion. X plus 1 whole to the power of 4. Obviously, we will be having 5 terms. So first of all, let us take the Pascal's triangle, and you are seeing when we have a power of 4, in our previous question it was having a power of 6. We have to come to the 4th row or 5th row or 6th row, whatever is the value of n. We cannot directly get the coefficients of the required row. We have to always start from the very first row. That is one of the drawbacks of this Pascal's triangle method for getting the coefficients. Because if the value of n is equal to, say, a large number, it may be 20, it may be 50, it may be 100. Obviously, you cannot just go on adding the numbers, and if it is, I have said 20 is the smallest number that I have said. Most probably I have taken 20, 50 and 100. So 20 is the smallest, and even if we want to have the coefficients of the 20th row, imagine the amount of time we will be spending on just getting the previous rows. And we cannot avoid that. We cannot directly come to the 20th row. That is one of the major drawbacks of this Pascal's triangle. It is a very easy method, but it is applicable when and only when n value is small. Okay. So the first row is 1 and 1, second is 1, 2, 1, third is 1, 3, 3, 1, and fourth is 1, 4, 6, 4, 1. Okay. So x plus 1 whole to the power of 4 is equal to, we start with 1, I am not writing 1. So x to the power of 4, because the first term will be getting raised to the power of n. Second term's power starts with 0, 1 to the power of 0 is 1. So the first term is only x to the power of 4. Second term is having the coefficient of 4. So 4 times x to the power of 3, because the powers of x will be going on decreasing by 1 each time, and now we will be having 1 to the power of 1, so it is 1. Okay, I am writing 1, okay. I could have skipped the 1 part because I think because you are new to this binomial expansion, that is why I am writing the 1 explicitly. Otherwise I would have skipped this part, because any number multiplied with 1 and 1 raised to any power is 1, and any number multiplied with 1 is the same number. So this part can be skipped. Okay. But since you are new, I am including this part. So 6 times x to the power of 2 times 1 square, and then it is plus 4 times x times 1 cube, 1 to the power of 3, plus it is 1 to the power of 4. X to the power of 0, I am not writing x to the power of 0, I have not written 1 to the power of 0 over here. So that is the expansion. And it is x to the power of 4 plus 4x cube plus 6x square plus 4x plus 1. Okay. This whole thing will get multiplied by 2x plus 3. So 2x plus 3 times x to the power of 4 plus 4x cube plus 6x square plus 4x plus 1 is equal to, first of all, I'll be multiplying all of these 5 terms by 2x. Okay. So 2x times x to the power of 4 will be giving me 2x raised to the power of 5 plus 2x times 4x to the power of 3 is 2 times 4 is 8, and x to the power of 4 plus 2 times 6 is 12, and x times x square is x to the power of 3. I'm not going into the multiplication process in detail because I think you know how to multiply polynomials. Okay. Then we come to 2 times 4, it is 8 again, and x times x is x square, and 2x times 1 is 2x. Next, we do the same thing, but this time we multiply by 3. So 3x to the power of 4 plus 12x to the power of 3 plus 18x square plus 12x plus 3. Okay. And now coming to the simplification part, so we have to group the like terms. 2x to the power of 4 and 8x to the power of 4, and over here we are having 3x to the power of 4. Okay. So it is plus 11x to the power of 4, 12x cube and 12x cube plus 24x to the power of 3 or x cube. 8x square and this is 18x square plus 26x square, okay, plus 2x and 12x, 14x plus 3, okay. So this is our final answer for our question. Expand and simplify 2x plus 3 times x plus 1 raised to the power of 4. Okay. So let us move on to the next question. Find the coefficient of a to the power of 3, b to the power of 3, that is a cube times b cube, in the expansion of 2a plus 3b to the power of 6. Again a power of 6, so we have to go to the 6th row. This is the major drawback of using the Pascal's triangle for getting the coefficients of the binomial expansion. Because as the value of n gets bigger and bigger, it becomes really difficult and time consuming to get the required row. Okay. So let's start with our answer. (2a plus 3b to the power of 6). We have known about the binomial expansion when we had the binomial expression as a plus b. This was raised to the power of n. But in place of a, we are having 2a. In place of b, we are having 3b. No problem. Whatever we are having, this is the first term and this is the second term. Since the power is 6, we will be having 7 terms in all, and this is the first term. So its power should be, the first term's power will be starting with 6 and decreasing by 1, and the second term's power will be starting with 0 and increasing by 1. All these things we know, and the coefficients will be obtained from the Pascal's triangle. So let us first of all construct or draw the Pascal's triangle. 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, 1, 6, 15, 20, 15, 6, 1. Okay. So now we start over here. 2a plus 3b to the power of 6 is equal to 1 is the coefficient of the first term and times, this is the first term, 2a raised to the power of 6. That is, okay, let me write these things and afterwards I'll be simplifying. 2a raised to the power of 6 and times, I write 1 as well. 1 times 2a raised to the power of 6 times 3b raised to the power of 0 plus 6 times, I'm taking the coefficients from this row, 6 times 2a to the power of 5 times 3b to the power of 1 plus 15 times 2a to the power of 4 times 3b to the power of 2 plus 20 times 2a to the power of 3 times 3b to the power of 3 plus 15 times 2a to the power of 2 times 3b to the power of 4 plus, I should have started a little left. Okay. So plus 6 times 2a to the power of 1 times 3b to the power of 5 plus 1 times 2a to the power of 2a to the power of 0 times 3b to the power of 6. Okay. Now we have to simplify. Okay. So this is 64 a to the power of 6. This is fine. But for the second term, it is 6 times 2 to the power of 5 is 32 times 3. For that, we need the calculator. 6 times 32 times 3. 6 times 32 times 3. Okay. This is equal to 576. 576. Actually, we do not need all the terms. We can get the coefficients, like we can multiply the numbers and write all the terms. But we do not need all the terms because they are saying, what is the question? You have to find the coefficient of the term which has a to the power of 3 and b to the power of 3. Only the coefficient of that term. Okay. So, it is fine if you write these, but that will be some extra work. And obviously, you will not be having any extra time during your examination. So, what you should be doing is, this is the term which is containing x to a to the power of 3 and b to the power of 3. You have to just get the coefficient, that is all the numbers you have to take. It is not just the 20. Okay. You have to take all the numbers, that is 20 times 2 to the power of 3, that is 8, and 3 to the power of 3, that is 27. I am writing this as plus dot 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 because I am not interested in getting all the numbers. It is 3 raised to the power of 6 and b raised to the power of 6 is the last term. But we are rather interested in only this term. So, it is 20 times 2 to the power of 3 is 8 times 3 to the power of 3 is 27. Okay. So, 20 times 8 times 27 is equal to 4320. Okay. So, the answer is 4320. And mind you, we will not be writing a to the power of 3 and b to the power of 3. Had they said that give the term containing a to the power of 3 and b to the power of 3, our answer would have been 4320, a to the power of 3 and b to the power of 3. But they have not asked about what is the term which contains a to the power of 3 and b to the power of 3. They have asked for the coefficient of the term, coefficient of a to the power of 3 and b to the power of 3, which is only this part. If they ask for the term, then you give the whole thing. If they ask for the coefficient, you have to just give this part. Whatever part has been said, you just exclude that part, and whatever part is remaining from the term, you have to give that part. That part will be mostly equal to a number, but it can be a variable also. Okay. So, it is better to know that whatever is given in the question, you just exclude that part, and whatever is remaining from that term, you give all the remaining parts, every factor of the remaining part from the remaining part as the answer. That will be the coefficient. Okay. So the coefficient of a to the power of 3 times b to the power of 3 is this number 4320. This you have to remember. You cannot give the coefficient as only 20, because you cannot say because we are getting this 20 from the Pascal's triangle, therefore the coefficient is 20. No. Okay. Because the Pascal's triangle assumes that you are having a plus b whole to the power of n as the binomial expansion. But in our case, we are having 2a plus 3b raised to the power of 6 and not a plus b. Okay. So the coefficient will also not be equal to 20. Rather, it will be equal to 4320. Okay. So students, we have understood how to get the coefficients, how to get the terms of the binomial expansion using the Pascal's triangle for the coefficients. And we have seen the drawback of using the Pascal's triangle as well. So in our next session, we will be starting with the NCR. What is that? We'll be knowing in our next session. Okay? So let us stop over here for today. Thank you for watching this video till the end. We'll be meeting very soon. Till then, bye.